Welcome back to Quantum X. Today, we're looking at a very specific project. One man, working alone, building a full garage using reclaimed wooden pallets. From a technical standpoint, this isn't just a DIY build. It's a real-world study in temporary structures, load paths, and working with materials that were never meant to be consistent. Pallets were never designed to be buildings. They're made to handle compression, not bending, not wind loads. That means every decision here is a calculated risk and an opportunity to engineer smarter. The builder has to understand where pallets can act as structural framing, where they should remain non-load-bearing walls, and where reinforcement isn't optional, it's mandatory. In this video, we're not just watching what he builds, we're breaking down why certain choices hold and why others don't survive over time. Stay until the end, because this is where real-world experience meets raw material reality. The project begins with the foundation, the one element that ultimately determines how long this garage will last. First, a layer of crushed stone is spread across the ground, forming a proper drainage base. Technically, this layer breaks capillary moisture rising from the soil and helps distribute loads more evenly. Next comes the wooden formwork. It's simple, low profile, exactly what you'd expect for an auxiliary structure, but precision still matters. Alignment, tight joints, and clean edges here directly affect the durability of the concrete perimeter. Then, steel mesh is installed. Even for a pallet-based structure, this choice shows technical awareness. Concrete handles compression well, but tension is its weakness. The mesh isn't there for heavy loads, it's there to control cracking. Finally, the concrete is poured. If every previous step was done correctly, this slab becomes a stable, long-term base for a lightweight structure. Once the concrete base has cured, the build moves into anchoring the structure to the foundation. Timber base plates are placed directly on the concrete and secured with anchor bolts. Structurally, this creates a rigid connection between the ground and the wooden superstructure. If this anchorage fails, the entire building can shift or twist under lateral wind loads. Next, the wooden pallets are cut down to size. Pallets are inconsistent by nature, so removing weak sections and keeping load-bearing members is critical. These pallet frames are then screwed directly into the anchored base timber, forming the first vertical walls. At this stage, the builder leaves openings for windows. Wooden pallets have a frame-like structure, which makes them suitable for reuse as wall framing in garage builds and auxiliary structures. Mechanically, pallets are made of parallel timber slats connected by spiral nails. This configuration handles vertical compressive loads reasonably well, ideal for lightweight walls. However, they were never designed to resist bending or torsional forces. In this project, the pallets function strictly as infill framing, not primary load-bearing elements. Their load capacity depends heavily on timber quality, nail density, and anchorage to the foundation. Another key factor is the pallet's natural spacing. These gaps allow airflow, but without additional treatment, they significantly reduce wall stiffness under wind loads. For pallets to work effectively as wall frames, they must be securely anchored to the base and reinforced at corners and around openings. Each individual pallet panel is screwed directly into the concrete base, establishing an initial anchor point for the wall system. However, fixing each panel alone is not enough to create a stable wall. To tie the pallets together, the builder inserts a timber beam through the pallet structure itself, allowing lateral forces to transfer from one pallet to the next, reducing vibration and torsion under wind loads. This solution works especially well with pallets because their open structure allows timber insertion without dismantling the frame. Simple but highly effective in increasing overall wall stiffness. At this point, the pallet wall stops behaving like separate pieces and begins functioning as one unified structural element. The garage is designed with a 3 by 5 meter footprint, a typical size for a single-car garage, compact but functionally adequate. It is built directly adjacent to an existing shed. From a layout perspective, this provides wind shielding on one side, significantly reducing lateral loads on the pallet walls, which are lightweight by nature. To reach the required wall height, the structure uses 2 stacked rows of wooden pallets. A single pallet row would be too low for practical use, but stacking 2 introduces higher demands on wall stability. In this configuration, the joint between the 2 pallet rows becomes a potential weak point. Without proper connection, the wall can hinge or fail at mid-height. That's why vertical alignment and continuous load transfer from base to top are critical for this wall system to perform safely. Around the window openings, the pallet panels are reinforced with additional timber members. Structurally, any opening creates a disruption in load paths within a wall. With pallets, this issue is amplified due to their inherently open frame. The added timbers provide a continuous fixing surface for the window frame. This prevents the window load from being transferred to thin pallet slats, which are prone to cracking or screw pull-out over time. Beyond securing the window, these reinforcements help redistribute wind forces around the opening, reducing vibration and wall tearing under strong gusts. Without this step, the window would quickly become the first failure point in the structure. The connection between the 2 stacked pallet rows is handled with great care. At this height, weak joints would cause the wall to behave as 2 separate masses, with failure likely occurring right at the connection line. Above the door opening, however, the builder faces a real-world constraint.
no timber long enough to form a continuous header beam. Instead of forcing a short, undersized beam, he chooses to divide the opening into multiple smaller door frames. Technically, this spreads the load across several shorter members, reducing bending moments on each one. It's a practical field decision, not ideal, but structurally sensible given material limitations.
With the wall framing complete, the build moves into the next phase, roof construction. Because the garage is built directly next to an existing shed, the builder decides to extend the garage roof over one side of the shed roof, creating a single, unified roof system. From a technical standpoint, this is a smart move. A continuous roof reduces exposed edges, limits wind-driven rain, and takes advantage of the shed's already stable structure. However, it also means roof loads must be carefully managed, as they are now shared between the pallet walls and the existing building. To control this, he begins installing wooden I-beam joists. This type of beam offers an excellent strength-to-weight ratio, providing bending resistance without adding excessive mass. The I-beams act as load distributors, spreading roof forces evenly into the wall system below, keeping the pallet structure within safe working limits. The entire roof system is built using 9 I-beam joists spaced at approximately 65 centimeters apart. Technically, this spacing is well suited for a lightweight roof, close enough to distribute loads evenly without adding unnecessary weight or material cost. At this joist spacing, loads from roofing, rain, and wind are divided and transferred evenly into the pallet walls below. If the spacing were wider, the roof sheathing would be prone to sagging. Too tight, and the roof would become unnecessarily heavy. Using 9 I-beams also allows the roof to behave as a rigid diaphragm, reducing vibration and torsion under strong winds. In a pallet-based structure, precise roof load control is critical to the long-term survival of the entire build. The I-beam joists are secured using perpendicular steel brackets, screwed directly into the existing shed roof structure. Technically, this junction is the most sensitive point of the entire roof system. It must resist pulling forces from the new roof while accommodating slight movement between the two structures. For that reason, the fasteners are installed carefully, allowing the steel brackets to function as load transfer connections, not rigid failure points.
At the junction between the two roofs, the builder adds small timber members. The purpose is straightforward: to create a perfectly flat surface for installing the OSB panels. If the roof plane is uneven, the OSB is forced to bend, leading to warping and joint cracking over time. Technically, these small timbers act as leveling shims. They are not primary load-bearing elements, but they directly affect the long-term durability of the roof deck. Once the structural connection is complete, a waterproof membrane is applied along the joint. The goal is not absolute waterproofing, but to block wind-driven rain and capillary water intrusion. Only after this step are OSB panels installed over the new garage roof. This sequence keeps the structure dry and stable before the roof system is fully locked in. Once the roof surface is fully leveled, the builder begins installing OSB panels across the roof. Before fastening the first row, a string line is stretched to establish a straight reference. Technically, this step is critical for error control. A small misalignment in the first row will propagate through every row that follows. The first OSB row determines the straightness of the roof edge, the alignment of panel joints, and how well the roofing layer above will seat. Each OSB panel is positioned so that all joints land directly on I-beam joists, avoiding unsupported edges, a common cause of sagging and roof noise. At this stage, precision matters as much as material choice. A roof that starts straight will remain stronger over time. At the junction between the two roofs, the builder carefully cleans the entire area, removing debris and trimming away excess wood. Technically, this step is essential. Wood offcuts and dust trap moisture, which is one of the primary causes of rot and mold over time. Once the surface is clean and level, rock wool mineral wool is installed at the roof transition. This material offers high heat resistance, does not absorb moisture, and is non-combustible, ideal for junction zones between roof systems. Finally, the OSB panels fully cover the roof surface, creating a continuous, unified roof plane between the existing shed and the new garage. Structurally, this is the moment the roof begins to act as a single system. OSB is not just a base for the final roofing layer, it functions as a shear diaphragm, preventing the I-beam joists from shifting or twisting. With the roof system complete, the builder moves on to installing the windows. First comes the wooden window framing. The openings were pre-planned during the pallet wall construction and are divided into 3 smaller window units. Technically, this reduces the load on each frame, which is especially important for pallet-based walls. The timber frames are securely fixed to the reinforcement members installed earlier, creating a precise mounting surface and locking the opening, a known weak point in lightweight structures. Next, the window units with small grid frames and glass are installed. This design provides ample natural light while still blocking rain and direct wind. In a garage, windows don't need to be large. They need to be well placed, properly proportioned, and correctly installed to protect the structure inside. Around the gaps at the window frames, the builder applies expanding foam to seal them completely. Technically, this is a small but critical step. The foam blocks air drafts and wind-driven rain while compensating for tolerances between the timber frame and pallet structure, which are rarely perfectly precise. The foam is not load-bearing, but it protects the window frame from moisture intrusion, reducing long-term shrinkage and timber decay. Once the windows are sealed, he turns his attention back to the existing shed roof. Now that the new garage roof extends over it, part of the old roof becomes redundant. He cuts away the covered section of the shed roof, gaining additional interior space. This is a practical space optimization step, done only after the new roof system is fully secure. On the exterior, the builder proceeds with installing wind barrier panels across the pallet walls. Technically, this layer serves a clear purpose. It blocks direct airflow, reduces wind pressure on the walls, and protects the pallet structure and insulation from moisture. Given the naturally open nature of pallet construction, the wind barrier helps the wall system behave more predictably, especially under changing weather conditions. Installation progresses smoothly. The surfaces were well prepared in earlier stages, allowing the panels to be fixed quickly and accurately. More importantly, the entire task is completed ahead of schedule. This reflects solid technical decisions made from the start, from foundation to walls to roof, keeping the build efficient and free of major rework. For the roof, the builder opts for low-cost roofing panels as a temporary solution to withstand the winter season. From a technical standpoint, this is a practical choice. In cold and damp conditions, the priority is not appearance, but keeping water, snow, and cold air out. These panels don't offer long-term durability, but they are sufficient to protect the OSB deck and timber structure during the harshest months. What matters most is installation quality, proper overlap in the direction of prevailing winds, adequate fastening, and ensuring water is always directed off the roof. This approach allows the structure to survive the winter safely while leaving room for a more permanent roofing upgrade later on. Inside the structure, he begins working on the wood stove area, a task requiring far greater precision than the rest of the build. The stove he purchased is modified first.
the rear exit flue is replaced with a vertical chimney pipe. This setup improves draft stability and reduces the risk of smoke buildup in an enclosed space.
The fireplace was thoughtfully designed to allow the chimney's outlet to be rerouted. Once the chimney had been redirected, he carefully welded the original opening shut. Inside, the walls were lined with thin stone slabs, creating an insulating layer that both protected and reinforced the interior.
At the wall where the stove will sit, he installs rock wool insulation, a fire-resistant material that prevents heat transfer to the pallet-based wall system. The insulation is then covered with a weather barrier, protecting the assembly from moisture before being sheathed with OSB panels. Finally, the stove area is finished with thin stone cladding, adding a non-combustible shield and distributing heat more evenly during operation. This step ensures the structure can safely endure the winter while maintaining the highest level of fire protection possible.
The thin stone panels are carefully measured and cut to fit tightly around the chimney penetration and fully cover the corner wall where the stove is installed. Technically, this zone allows no margin for error. Even small gaps can expose the timber structure behind to heat and smoke. Before installation, the stone panels are pre-drilled. This prevents cracking and ensures precise screw placement. The stones are then fastened directly into the OSB panels behind them, creating a rigid, non-combustible protective layer that keeps the stove assembly stable during operation. In the next step, he installs an overhead door, a common solution for garages with limited space that still require safety and a clean appearance. This type of door is made up of multiple hinged panels. When opened, the door slides upward and rests parallel to the ceiling, freeing up both exterior and interior space. Its operation relies on a guided track system mounted along both sidewalls and curved toward the ceiling. Rollers attached to the door panels run inside these tracks, ensuring smooth and controlled movement. To reduce operating effort, the system uses spring-assisted counterbalance, typically torsion springs. These springs offset most of the door's weight, allowing it to be lifted manually with minimal force or powered by an electric motor if desired. For a pallet-based structure with constrained space, this overhead door provides a technically sound and efficient solution. After completing the main structural elements, the builder moves on to insulating the pallet walls. Structurally, pallets offer a clear advantage. They already contain open cavities. These cavities function much like conventional wall studs, making them ideal for installing insulation without major modification. The insulation is cut to fit each cavity precisely, ensuring there are no large gaps, as gaps are the primary source of heat loss. Once the insulation is in place, a covering paper layer is applied over the entire wall surface. This layer keeps the insulation secure and helps block air movement and dust before the interior finish is installed. In a pallet-based structure, insulation isn't about meeting residential codes. It's about thermal and moisture stability, making the space more comfortable and extending the life of the building. He installs long, narrow timber battens screwed along the length of the roof I-beam joists. These battens are not primary load-bearing elements, but they play a critical role. First, they create a support system for the insulation, preventing sagging or displacement over time. Second, they provide a continuous fixing line for the OSB panels that will later cover the underside of the roof. This approach turns the ceiling into a compact, well-organized system, insulated, aligned, and ready to be fully locked in the next stage. In an enclosed space like a garage, the roof and walls are the primary paths for heat loss. During winter, metal and concrete surfaces absorb cold rapidly. Without insulation, the interior temperature can quickly match the outside environment. Insulation helps stabilize internal temperatures and reduces condensation on walls and roof surfaces, one of the main causes of mold, timber decay, and metal corrosion. For garages used as workshops, storage spaces, or auxiliary living areas, proper insulation also reduces heating demand and extends the lifespan of the structure. After completing roof insulation, the builder moves on to locking in the pallet walls. OSB panels are installed across the entire interior wall surface. Structurally, this is more than a finishing layer. It acts as the primary shear surface of the pallet wall system. When the OSB is screwed in with proper spacing, the individual pallets are tied together into a single box-like structural wall. Lateral rigidity increases significantly, which is critical for a garage with wide openings and long spans. The OSB also serves as a protective layer, shielding the insulation from drafts, rodents, and moisture. At this stage, the pallet walls are no longer temporary framing. They become a stable, load-ready structure.
At this point, the garage structure is complete. The foundation is stable, the walls are fully locked, and the roof is integrated with the adjacent shed. The next steps focus on practical functionality. First comes spreading crushed gravel in front of the garage. Next, he installs a diesel heater. Finally, a workbench is added.
Before winter arrives, he needs to finish the surface in front of the garage. The process begins with laying a geotextile fabric as a base layer before spreading gravel. It's a simple step, but one with a major impact on long-term ground stability. First, the fabric acts as a separation layer. It prevents the gravel from sinking into the soft soil below, keeping the surface clean and structurally stable over time. Second, it helps control weed growth, blocking sunlight and preventing seeds from reaching the soil, which reduces future maintenance. More importantly, geotextile fabric allows water to drain freely while filtering out fine soil particles, preventing mud from rising through the gravel during heavy rain. Finally, it helps distribute vehicle loads evenly, especially under heavy equipment and frequent traffic, reducing rutting and ground failure during winter conditions.
Next, he installs a diesel heater to prepare the garage for winter use. At the same time, the old shed wall is repainted. This wall was previously exposed to outdoor conditions. Now, with the garage built alongside it, it has become an interior wall. Repainting improves appearance and provides better protection for the timber against moisture and heat.
The walls were sanded and painted gray, matching the interior color of the warehouse. While not structural, this step improves visual continuity and adds an extra layer of protection to the timber in a space affected by heat and moisture changes.
In terms of operation, the diesel heater works with a sealed combustion system. Fuel is pumped into the combustion chamber, mixed with air, and ignited at high temperature. The heat is transferred to a heat exchanger where cold air is drawn in, heated, and then blown through ducting into the workspace. Exhaust gases are vented outside through a separate flue, keeping the interior safe. Between the wood stove and the diesel heater, a horizontal metal pipe runs along the wall. This pipe likely functions as an auxiliary heat distribution or exchange system, helping move warm air and optimize heating efficiency across the larger garage space.
The diesel heater provides stable, controllable heat, starts quickly, and works well when the space needs to be warmed for short periods. It's ideal for intermittent use. In contrast, the wood stove delivers high, sustained heat, making it effective for maintaining warmth during prolonged cold conditions, especially when firewood is readily available. Using both systems offers flexibility: diesel for fast startup, wood for long-term heat retention. More importantly, it creates energy redundancy. If one system fails, the other can still keep the workspace operational through winter.
Power for the diesel heater is supplied through a transformer stepping down 230 volts to 12 volts. This low voltage system runs the fuel pump
blower fan, and control unit. This setup is common in standalone heating systems, offering improved safety in humid environments.
Finally, he designs and completes the main workbench inside the garage.
The workbench frame is built from solid square timber members sized to resist twisting and vibration during heavy use. The bench height is set for comfortable operation, allowing extended work without unnecessary strain. Two sides of the bench are screwed directly into the wall, making the wall part of the load-bearing structure. As a result, the bench requires only a single wooden leg at the front to support vertical loads. This design reduces material use, increases overall rigidity, and keeps the space beneath the bench clear and accessible.
The work surface is made from a 5 mm thick steel plate, stiff enough to handle impacts, clamping forces, and heavy tools without flexing or deformation over time.
The steel worktop is carefully sanded smooth, removing burrs and sharp edges. It is then painted black, reducing light glare, masking scratches from daily use, and providing long-term corrosion protection.
Behind the bench, a tool hanging board is installed, organized for quick visual access, reducing wasted movement and keeping the workspace efficient. Under the bench sits a multi-drawer steel cabinet, used to store heavy tools and supplies. Its weight also adds stability, anchoring the entire workstation during demanding tasks. At this point, the garage is no longer just a shelter. It has become a fully functional workshop, ready for year-round use.
From a stack of old wooden pallets, a garage and working workshop has taken shape. Simple, practical, and built to last.
This project isn't about perfection. It's about thinking clearly, building smart, and making the most of what's already available. If you found this video useful, hit like to support the channel, subscribe for more real-world builds, and leave a comment to share your thoughts or questions. Thank you for watching till the end. See you in the next project on Quantum X.